Hello, welcome to Topper Machine. Today's job, we are going to turn this pile of parts into a couple of rollers for an etching press. So these are pretty straightforward. I got a drawing from him. Very simple rollers, inch and 3/16 shaft, couple of 3 plates in there, all welded up. Pretty simple, straightforward. So let's go ahead and get on the Monarch, and we'll actually bore our plates first to fit 3" and 3/16 shaft. All right, so we're gonna just do these quick and dirty. They are oversized, and I had them cut that way just to speed the process up. Once we bore them, then we'll put them on the shaft, weld them up, and then I'll turn the discs to the size we need to fit those tubes. But in order to get the hole in them, we're gonna do this quick and dirty. And we're gonna use a drill and then a reamer. Simple, quick, effective, and that's all we really need to do to get this to work. All right, let's see how my drill grind is. I've got a drill grinder coming, same exact grinder that Keith Rucker has at 6G Sellers. Bought it from a local guy because I do have a lot of drills. And so we'll just see how I did by hand. All right, well that was a lot more wobble than I like. We'll see how it did. It'll be just fine, I'm sure, but I may center drill the next ones just to true it up and make sure we're good. Oh yeah, we're looking good. Actually, that went really well. There she is, and she does fit on there nice and snug, which is exactly what we want. So perfect. That'll keep it more straight when welding. All right, well, I'm gonna go ahead and get the rest of them done here, and then we'll move on to the next step. All right, I got all those plates done, and then we had a little emergency. I had to run to town with the wife, and town is, if you want to go to any bigger town around here to get anything you absolutely need, it's an hour drive one way. So now I'm several hours late into this project, need to get it done. So what I got going here is I've got my 3J collet chuck on, which goes up to 1.5 inches, I believe it is. I got the 1 3/16 collet in there for our 1 3/16 shaft. We're gonna go ahead, face it off, center drill it, and then flip it off, face it, center drill the other end, and then this shaft will be ready to go over for, this is the shorter one. The other one will get the keyway cut in it. So. Put a little anchor lube on there and center drill this guy. And now you're probably wondering really why I'm using the collet chuck versus the 3-jaw. And the reason is the accuracy. This is significantly more true holding, but also when it comes to turning the OD of that drum, it's going to hold it a lot better than the 3-jaw will. All right, this one's done. I'll get the other one drilled, and then we'll mill that one keyway. All right, so I got the shaft set up here in the mill. I'm all indicated in right where I need to be. I got to take 138 thousand steep to cut this keyway. We're going to do it a 1/4 inch end mill. I'm going to do it in one pass. Now, you may notice something on this mill that does not look right. There's another head back there. That head I bought on Russell Guerin's first sale, and that is a Bridgeport cherrying head. So stay tuned to the channel. We'll have a video of that. I just got the collets for it. I took the Bridgeport B3 collets, which are really rare, but I got some collets, found them on Marketplace. So they are here, and when I get a little time, we'll spin this thing around and we'll test that head out and see what it'll actually do. All right, let's get started here. I got this quill locked. We're just gonna come up till we touch. There it is. Throw my readout backer off. Come up 138. Come in till I touch. Zero my readout again. I'm going to back it out just a touch, and we'll use the power feed. Actually, I'm going to switch to this bottle. This is anchor lube that I thinned a little bit with water so it gets in there a little nicer. Do a quick check here with the caliper. Beautiful. I could throw gauge blocks in there, but the tolerance on that print didn't require it to be super tight. I actually wanted it a little loose, but we're dead on. We're good there. So now we'll go and get our discs on and get them welded on. All right, so I got it roughly where I need them. I'll just double measure, but I'm gonna go ahead and get these welded up. And then I'm going to give away one of my biggest secrets of building rollers, something that I should not show or tell, but I'm going to share it anyway because it's one of the biggest secrets about building these rollers for longevity and just strength all around. All right, we're all welded up. I'll bring you in and show you what I did. Now, over the years, I've built a lot of rollers, a lot. In fact, one of my customers that just recently closed up, that's all I did for him was rollers. Much larger scale than this, but something we learned early on was about the heat affected zone of the weld. So in the shaft, if you weld all the way around the shaft, especially one this small, you make a brittle spot. Here, we're welding lengthwise and then up on the plate, giving it a lot more surface area, but not putting that heat affected zone into the shaft as much in a circular motion, but as a lengthwise. And that has proven itself time and time again with many rollers I've made. I used to do anywhere from 100 to 200 rollers a year for that one customer on a much larger scale than this. And as soon as we started doing this, all of the failures went away. We looked at the ones that were made before I started doing it, and they were all done the same way as I started doing them, welding all the way around, and they were all failing the same way too. So as soon as we took the weld all the way around away and did it this way, we cured all of our problems. So any cracking doesn't happen anymore there. And then on this center one, which is just a support and really isn't all that critical, we skip weld. So as you can see, I did the 4 quadrants. So that's all that needs. It's just there as a little bit of extra support. And this one is done. It'll cool off, and then we'll get it up in the lathe and turn it down to size to fit the tube. So it's the next morning, and it's all cool. I got it up here in the lathe. I already measured the bore on the tube, and I got between 7,230 and 7,235. So we are going to shoot for 7,225. Give myself 5 to 10 thousandths clearance. Not that it's an issue. We're going to turn the OD when it's all done, weld it up, and finish it out. I'm using the collet chuck again because of the rigidity, the trueness of it, the strength, but also there's more of a gripping surface on this shaft, and being this is a small shaft, you know, you can't get a lot of good grip on it, so we're going to use the collet chuck, take light passes so we don't slip it, but with the collet, if we do slip it, it's not going to do as much damage as a chuck would. We got about 50 to go. All right, so we got a little bit of chatter there, but we are right at where we want to be. Yeah, 226. So we're actually okay. That'll fit just fine. I'll move on to the center one, and then this one. This one will probably give us more difficulty. Right, so I slowed my spindle down just a little bit. We'll see if that helps with the chatter. I know this one's probably going to give us the most trouble. So I'm actually going to take smaller cuts. All right, well, that actually looks like crap. And I expected that being here in the center. I'm going to try slowing down my feed rate. We'll take another light cut, see where, and then measure and see where we're at. All right, I knew this center one was going to be a problem all the way around, but just because there's not a lot of support with this small shaft. A bigger shaft would do better, or smaller plates. The other shaft will probably do a lot better than this one. So looks like we can go another 10. All right, well that mostly cleaned up the chatter. That came out actually really nice. So the center one we're gonna have to run really slow just to make sure we don't get a lot of chatter that'll probably screw up our shaft a little bit. Now this one should be pretty rigid because I'm clamped right up tight to it. So let's get this one done. We can speed it back up, should be good on this one. So I actually took 75 on that first pass, and because it's supported so close to the chuck here, no vibration whatsoever. That came out beautiful. This first one, we got some chatter. That was taking 50 in a pass, and that still isn't bad. And then the center one, we had to slow way down. So I may have to slow this one down too to do it, but I want to do it this way. That'll make it as true as possible. All right, now I'm just going to come in with a round insert and just hit those edges just to give them a little cup for welding. Not a lot. And then on the inside to just get the burr off. All right, that's done. We'll get it out of here. I'll test fit it in the tube, make sure it fits, and then I'll just knock out the other one, and then we'll go to welding them up. Wow, that's a beautiful fit. Then listen to this. Kind of a vacuum there. Well, awesome. That's the kind of fitment I like to see on these. I've done a lot of rollers over the years, and when you get them like this, things go really well. I mean, it's just a nice fit all around. It works well, goes together great. So I'm going to go ahead and get this one knocked out. Then we'll take them back, weld them up, and come back and do the machining once they cool off. All right, so as you can see, I got them back here in the weld shop. I am going to go ahead and find a cardboard tube or something to protect the shaft, and then I'm going to go ahead and throw just a couple tacks to hold it in place so it doesn't move, and then we'll move it over to the weld positioner here, and I think that'll support it enough to just run it and run a bead and get a beautiful bead on it. We'll see how it looks. If I don't like it, then I'm going to switch over to the TIG welder. So I'm going to MIG this first, but TIG it. If I don't like it, I'll just come back over what I did, blend it in beautifully. You'll never even know I messed up. All right, I couldn't find a cardboard tube, so I made one out of a political ad that came in the mail. Surprisingly, this cardboard they print this stuff on is actually useful for something, protecting shafts when you're welding. You know, I wish they'd print that stuff on toilet paper so it was really useful. All right, it's in the positioner. It's actually supporting it really well. And if my speed is good, which it looks like it'll be about right, this will make a beautiful weld. So let's go ahead and get this sucker welded up. I'd say that came out pretty good. It looks like I could up my wire speed just a touch, but my roll speed here is pretty good. I think we're in good shape. Alright, so I got the big one here in the Monarch, and I'm not going to lie, I'm a little concerned about this because that's not a lot of shaft. So I am going to start right now, 225 RPM and feeding 7th hour rev, and I am not going to try taking much, but I'm actually going to face off this end. Actually, I'll touch off here, get this distance, face it off, and then we'll take a light pass, just see how it looks. Well, so far I'm surprised it isn't ringing like a bell. Well, considering how well that faced off, which that is from here to here, the distance in the drawing, and I just want to bring this up. It may look like that shaft is bent, wobbling, but it indicates out true, so that's kind of an optical delusion there. And now we're just going to touch off, and I'm going to take a nice light pass to start with. We're going to take 20. We're going to take 20 to start with, and just, we don't want to put too much torque on in the chuck. So yeah, just enough imperfection in this tube to throw it off that little bit, but she'll clean up pretty good, and it looks like I could speed up a little. I am getting just a touch of chatter out here more than I am over here, but I think I'll be able to polish that out at the end with the emery cloth, but this is coming out nice. All right, so after running that first pass, I actually decided to flip it around so I could just face this other end and get this length done. And I'm speeding it up. I think I sped up my feed rate. I think we can do this pretty quick and still get a good finish. So we're gonna try this. So the drawing calls for 22 inches with no decimal places. And I am actually just gonna take a nice little skim cut yet to finish that 100% cleanup, and then we will be good to start facing, or turning the dough. All right, we were doing good until we got about halfway. This is going to be a really tough one to finish. I'm going to have to slow this way down, try to keep that chatter out of it. Because of the small shaft size, this is not an easy project, but we'll get this done, no problem. So she's still singing a little bit, but I think we'll be okay. I can go and actually do something else while this is running. All right, guys, well, this probably looks really stupid, but it kept singing on me. It wants to be a singer. I don't know why. That's kind of the nature of the beast sometimes with these. So I got it attached at that end, and I got a weight hanging up here, and that honestly seemed to cure the problems. So it's just going to ride on there and just dampen that vibration. Maybe. Oh, you cunt. Well, guys, I've been doing this a long time, making a lot of rollers like this over the years, and I've never had one beat me up quite as bad as this one. So what I got going here is a 2x4 attached on that end, a weight on this end, taking out the vibration. That's helping a lot. I've also slowed down my RPM. I'm running 31 RPM, feeding at 7 thou and 3/10 a revolution. So a nice slow feed, and it seems to be cutting really well. It's actually coming out very smooth. I'm actually very happy with the cut. But it's going to take a while, so I am going to go ahead and work on another job while this is going, and just keep an eye on it, and hopefully it goes well. All right, we're about halfway, and it's doing very well. The 2x4 on there creating a little bit of pressure is taking out the vibration I was getting before, and actually that surface finish is very smooth. I'm very pleased with it. I think the customer will be happy with that also. So we'll go ahead and just get this guy finished up. All right, there we go, 100% cleanup. That actually came out really nice. It's not bad at all. I'll probably just polish it a little bit with some emery cloth, but we'll go ahead and chamfer the ends, take care of that, and then this guy is done. All right, to do the ends here, I'm just gonna use my round insert. I'm gonna just put a little chamfer using that radius. It's not gonna hurt me any. And then I wanna take that round insert, I'm gonna go inside, get it close, and then pull back and just clean up that sharp edge. There. And I'll do the same on the other end. Quick hit with the file on the ends here to just make sure there's no burr. Beautiful. Perfect. I'll just do a light polish. Well, that came out good. I'm very happy with this. I think my customer will be happy. You know, and it probably doesn't look the smoothest in the lighting and with the camera. As we've seen with other things, the camera just picks up weird stuff. But this is smooth. This is good. This is very good. So very happy with that. Not happy with how slow I had to run it and how it kicked my butt. But it was a learning experience too. I knew it would be a problem going into it with that small shaft that was going to affect the vibration and everything. You know, I think if we could have gone with a much larger shaft, I think this would have been a lot better off. But overall, I see no problems with this. So we'll go ahead and get this out of here, get it to the customer. I'll get the other one done, and we're going to end the video here. So until next time, get out in your shop and get it done right the first time.